Well, good morning, everyone. Thank you so much for attending our international admissions event here. So my name is Dr. Michael Frye. I am the chair of three programs actually here at the University Incarnate Word. So I'm the chair of engineering, which I think most of you all are here for this, for engineering. However, I also am the chair for computer information systems and cybersecurity systems. And I happen to be giving something similar to this morning's talk in another hour for those two programs for anyone that might be interested in those. I am very impressed with the countries that are represented today. A lot from the Southern Hemisphere. That's really that's very neat. Before I jump into today's very quick talk, just wanted to let you all know that we're teaching a artificial intelligence class in engineering. It's a senior level class. It's a very, very interesting makeup of students because actually most of the students are international. I think there's only two that are actually from Texas. And it's interesting because most of the students are from South America. That the common language is Spanish. Even we teach the class in English, but most of the folks are actually Spanish, and this is the one class where everyone is fluent actually in Spanish, even the professor. So that just kind of illustrates the very international makeup of UIW, where we have a very diverse student population from many nations, and we're very proud of that. And I wasn't expecting to see that in my machine learning class. But even something as high level as that, or as scientific as that, we have a pretty good makeup. So I do really appreciate you all taking time out today to listen to me talk a little bit about the program, the engineering program, and also hopefully you'll as we kind of go through the talk, come up with some good questions. Michaela will be watching the chat for us. And again, please don't be shy. If you have any questions or any clarifications, please send something on the chat, or if you want to, just unmute yourself and ask away. We're a very friendly bunch here, so I definitely want to answer all the questions. Kind of the point of today, what I'd like to do, the objective is two things. I want to talk a little bit about the engineering program per se. I'm hoping this will kind of elicit some questions. And additionally, I'd like to spend maybe 10 minutes, 15 minutes giving you a feel as to a mock class in engineering. And the one I picked actually is machine learning. I want to talk, it's kind of my forte. So I'm hoping between my kind of overview of the engineering program and kind of going over the mock class, it'll kind of give you a feel as to UIW and kind of what to expect in a class. So real quickly, you should be seeing my screen. I'm sharing kind of the overview of the engineering program. Again, my name is Dr. Frye. I'm the department chair for engineering. I am an electrical engineer. So if and when you attend UIW, you'll see me mainly in for the folks that are interested in, let's say, electrical stuff. I do teach engineering, mathematics, and computer programming, so you may see me in those classes. But for the most part, I teach upper level juniors and senior classes in electrical engineering. Just quickly, you can put this in the chat. Who here is interested in electrical? And Chris is saying hello, so I'm saying hello back. So we have awesome. We have engineering interest question. So we've got mechatronics seems to be the winner right now, which is not surprising. Some undecided. Let's see. Let's give it a couple more minutes. I know there's six of y'all have answered. 7 y'all, 8. We got about 30 more seconds. Looking at this, I am not surprised at the distribution of the programs. We have three primary tracks at the upper level. Electrical, which is what I'm responsible for. We have a mechatronics, which is typically the most popular track, especially from our friends from Mexico and from Central and South America. So I'm not surprised that mechatronics has the most interest here. For the folks that don't know what mechatronics is, it's kind of a combination of electrical and mechanical engineering with some computer programming and some project management. It's a degree that's needed a lot more in the manufacturing of systems and widgets, things like that. And we have two undecided, which is great. That's where my job comes in. And to help the undecided kind of get a feel as to maybe what track they want to go. Right now we have electrical, we have mechanical, which I'm surprised no one's doing that, and mechatronics. So hopefully for the folks that may be undecided, we will work with you over the first few years and see kind of where that goes. Okay, with that said, there is one question. If I'm not interested in any of those, is it okay if I put undecided? Yes, of course. The good thing about coming to UIW, since we are a private institution, we really like to tailor the degree to the student and to the student's interest. Artificial intelligence and machine learning, deep learning, that's been getting to be very popular over the last few years. What we found out was, students want to delve a little deeper into those topics, and our degree is flexible enough that you can kind of pivot. So if you're undecided, we can find definitely a niche for you, and definitely work with the faculty advisors to kind of determine that. So kind of next slide. Just real quickly, I'm actually calling from my research lab today. So I'm actually across the street from the main campus. I'm actually looking at the main Bonilla Science Hall, which is where most of y'all would take your classes. So wanted to kind of show a little bit about some of the stuff that students actually do here. We have a very strong research program for undergraduate students, and for me, I'm interested in robotics, specifically UAVs or drones. And what you're seeing here is our drone team flying outside, and we're running video through a computer system that the students developed, and it's able to identify power lines, the components like the insulator, the actual cross arm, as you can see right there, cabling, things like that. And we're working with a local power company to help automate their system. And I just kind of pitched this to say that we're kind of unique. We're focused on undergraduate education for engineers. So we don't have graduate students, we don't have PhD students. So meaning the classes will be taught by faculty members, and the research that's being done is being done by you all. And here's some more examples from the computational intelligence lab. This is our AI lab. We do autonomous cars. The lower left is actually something developed by Ulysses Franco. He's from Mexico, and he's very entrepreneurial, and he's helped us out with coding of autonomous car. You can see that track is identifying the track there on the lower left. So we're a pretty busy bunch when it comes to doing research. This research gains work experience for y'all and makes you very marketable when you graduate. This was a new one. It's a little dizzy, but the folks that know of Whataburger. We are actually at Whataburger back in May, helping them out doing some drone stuff, and we're actually at their corporate headquarters, which happens to be near UIW, and our drone team was flying this. So again, we're very busy. Lots of opportunities to engage in faculty-led research. This type of research, again, is very marketable. Especially here in San Antonio, there are a lot of startups looking for students that have experience as engineers and as computer programmers. UIW is, and I'm sure most of y'all know this, a private Catholic university. We do take our mission very seriously. And I think it's a very important part of being here at UIW, the mission. And just to kind of tee it up there for the first time if y'all have not seen this. So the mission kind of wraps up very nicely in 5 tenets: faith, education, truth, innovation, and service. For the engineering department, we really obviously focus on the education piece. We really want to make sure that we're graduating engineers that are marketable, that can get jobs, and we want our engineer graduates to be innovative, to give back to their community, give back to their their specific like business sector, and change the world and make the world a better place. We do a lot of service, and you'll hear a lot about that when you come to UIW. The specific school, these are equivalent to colleges, that you'll be attending if you're in engineering, is the School of Math, Science, and Engineering. We have lots of programs under there. So we basically handle all the sciences, all the math, and obviously the engineering technology area. We have a biology program, which happens to be the largest. There's about 600 students that are in biology. We have chemistry, environmental and earth sciences, engineering. Just to let you know, the engineering program is the second largest program within the school. Along with engineering is computer information systems and cybersecurity systems. So there's actually 3 different degrees that are issued by the engineering department. Not without saying, there is a mathematics department. They offer degrees in data science, which some of y'all have probably heard. It's getting to be a big thing. We have a meteorology, study of the weather, and a very strong nutrition program. The nutrition program is interesting. They actually have a graduate program with us. So as I said, the engineering, computer information systems, and cybersecurity systems is the second largest program within the school. There's over 200 students enrolled amongst the 3 programs, getting 3 different degrees. So we're very large. I bring that up because the first year, 2 years of the program, there's a lot of flexibility about moving amongst the 3 programs, or even amongst the 3 tracks within engineering. So for the folks that may be undecided or really unsure as to where they want to go, the faculty members really help facilitate working with the students to kind of determine where they want to go amongst amongst the 3 programs. And if you're in engineering, but you're not really sure, picking the right track. The minimum requirement to graduate from UIW is 120 credit hours. I highlight we actually have more for engineering, so now I'm going to talk about that in a sec. I kind of highlight in red, as part of the service component, there are 45 hours of community service that is required to graduate. We take that, again, very seriously. There are no exceptions to that. Again, 45 hours over 4 years is not difficult. And if you engage with the local engineering societies within engineering, should be plenty of opportunities for that. We have core. The core is required regardless of your degree. So everyone's taking core classes. I always have engineers saying, why do I have to take 9 hours of English? Why do I have to take, Comp 1, Comp 2 in English, in World Lit? Again, we are a private university. We take the liberal arts, and we are a liberal arts university, even though we have sciences and engineering. We take the liberal arts component of the degree very seriously, and we want you to be well-rounded. So there are a lot of classes over at what we call CHAWS, and they handle our non-science courses. So we do have a little heavy component on the history and religion and fine arts, but the idea is to, again, make our engineering students very well-rounded. And again, most students enjoy it. It allows you to meet other students in other programs, go to different buildings, and kind of just get a very well-rounded education here at UIW. Okay, questions before we kind of move on. And I see something in the chat. I just comment. Okay, so when you join UIW, you will have a faculty advisor. So there are, and I will talk about the engineering department in a bit. You'll actually be working at a minimum one semester, twice or at least twice a semester with your faculty department, faculty advisor to determine what your classes are for the next semester. And I think more importantly, what your future plans are. Are you going to graduate school? Do you want to go work? Your faculty advisor is there to help kind of work with you to determine kind of what direction you want. And we're about 50-50. About half our students go to graduate school to get a master's. A few students go get their PhDs immediately. And about 50% of the students go to the workplace. Let's see, we have a question. And I guess that's Michaela, this a question about improving English as a second language.
Sure. So we do require proof of English proficiency in the form of an English proficiency exam in order to enroll in classes. But we do have, great opportunities, like Dr. Frye was saying, the composition classes, the English composition classes definitely help all of our international students take those. We also have both a writing and learning center as well as a tutoring center that offer free services for our students, where you can set up appointments or just walk in if you need help with your essays or if you need help with any kind of class content as well.
And that's a great question. A question about demographics and is the coursework different amongst, say, an international student and a non, like a US citizen? No, it's the same degree for everyone, same homework assignment, same due dates and all that. Also, there was a question about calculus. I'll talk about that. There's a lot of calculus in our in engineering, not surprisingly. Right now, we require calculus 1 and calculus 2, and we're about ready to add calculus 3 to the degree. So yes, lots of math. I really encourage everyone, please get involved at UIW. Quite frankly, international students tend to be very engaged within the campus. There are special interest clubs. Say, if you're into basketball, there's a basketball club. There's pretty much a club for anything that you're interested in. There is a scuba club. There's the professional societies within engineering. We have the Institute of Electrical Electronic Engineers. So it goes across the spectrum from sports to professional societies to special interests. We have student government. I really encourage you all, when you come to UIW, please join these clubs. It's opportunities for leadership and also to keep you engaged. And I'm gonna hold off on that question about the calculus. I'll kind of talk about how the degree plan works in a bit. Bottom line question is, yeah, the math classes are required before we get too involved with the engineering classes, and I'll talk about that in a sec. Are there any athletes coming in that are Division I that are being recruited as athletes? And I know, like, from international, a lot of soccer and a lot of tennis and some basketball. For the athletes out there, again, we are a Division I NCAA program. What that means is we compete at a pretty high level. But we're kind of proud of the fact that our athletes are student athletes, and they're getting an engineering degree just like everyone else. They're busy. And what I can tell you about athletes that happen to be engineering students, they tend to have a higher GPA and do better in the program. And I think a lot of that has to do with the fact that they're very time constrained, they're very busy, and they have to focus, and they kind of stay on top of things. So we're always proud of our athletes. They're very busy, but they always do very well for us in the program. The question about how many degrees you can study at a time. We've had students, not a lot of them, but we've had double majors that will obviously require more time to graduate. But we've had students, the natural one is math. We've seen a couple double majors in engineering and mathematics. A lot of our students go engineering and get a minor in math because of the fact that you take so many so many math classes. So the question is, you can double, meaning you can get 2 degrees at the same time, but it's kind of rare because it does add an additional year to 2 years based on what that degree happens to be. But we do have a lot of minors. And yes, having an engineering major and a dual minor is possible. I've seen that happen a lot. An example of a dual minor would be, say, mathematics and like a business. Some folks have an interest in business, so they take a lot of marketing, things like that. So yeah, that's very possible. The kind of the point of going to UIW is the fact that our degree plan is very flexible. It's really geared toward each individual student. So it's kind of up to you all to kind of decide how you want to do it. Again, I'm a big proponent of, graduating as quick as you can. So I tend to emphasize get the engineering degree and then graduate. But again, I always encourage, if students are interested in a minor to get some additional skills, by all means. And yes, for calculus, it's good old calculus. It's integral calculus and derivative calculus that you would, some of y'all probably already had. So the faculty here at UIW, there's 8 of us. So we're a fairly large program. There are 2 mechanical professors, Dr. Ahona and Dr. Andy. There are mechanical. We have 2 computer information system professors, Professor Vumula and Professor Amari. They teach a lot of the programming classes for us. We have 2 cybersecurity professors, Dr. Para and Dr. Collins, and 2 electrical. So Dr. Chaglian and myself, Dr. Frye. So we're kind of broke out 2, 2, and 2. And again, I kind of bring this up because we are a big department. There are a lot of opportunities to engage with different type of professors with different technical backgrounds. And I encourage you all to meet all the professors because they bring in different perspectives and different experiences, and they're all very interesting and very friendly. Real quickly, since most of y'all are interested in engineering, let me see. I'd like to see maybe in the chat, what is engineering? And I'm keeping an eye on the time because I know we have about 30 minutes. And I'm taking some of this from my intro to engineering class. So just kind of tossing it out there. So what is engineering? And David's saying, learning how things work. Yep, that's a good definition. Problem solver, yes. Brandon saying problem solver. I like to, Olivia saying, using logic to solve problems in our society. I like that. Yeah, practical use, taking the sciences and making it practical. Exactly that. I see us engineers, we take the sciences, we take the mathematics, we take all the computer programming, we wrap it all together and we develop a product. We build something. I like to say we build things. For me, I work on drones. I like to build drones and make them fly. And I like that art. There is a lot of art in engineering, a lot of creativity. And it's very interesting that coolest person in the room. Yes, engineers are the coolest people in the room. It's not uncommon that most engineers have an artistic background of some sort. It ranges anywhere from photography to drawing to painting to writing. It never surprises me how artistic a lot of engineers are. A student that just recently graduated was very musical, very good on the guitar. So we are creative, and I think that creative portion is what makes engineering very, very strong. I'm just going to skip through all this. I want to talk about a little bit about the curriculum because I'm getting a lot of questions about that. So you'll notice that the minimum to graduate from UIW is 120 hours. we require more because we have so much math. So we do require the 36 hours of core. This is, again, your English, your history, your religion. Additionally, we require 32 hours of math and science. That's just math and science. And then we start engineering. And then we have what we call engineering core, which is almost 50 hours. And after that, you have the option of picking 3 tracks: mechatronics, which seems to be the biggest interest, electrical, and mechanical. And that all adds up to about 129. On average, most of our students graduate with more hours. We're typically running about 133, 134. So just to kind of let you know, our program requires some of the most hours in terms of graduating, which is why I tend not to emphasize the double major a lot, because of the fact that we're just so busy in our own program. But again, I encourage you all to go where your heart wants to take you. So kind of let you know, there was a kind of a question about the sequence. So before we really get into engineering per se, most students will be spending some time in the math and the sciences. I mean, getting the calculus 1, getting calculus 2 done, getting engineering probability and statistics done. There is some engineering lower core, which is engineering physics, introduction to engineering. So there will be some freshman and sophomore level engineering classes. We go through what we call gateway classes, which is a computer programming class and an engineering analysis class. This is engineering mathematics. So as you can notice, there is a lot of math before we even hit the upper level engineering classes. And I just kind of bring it out there, not to discourage anyone, but I just want to make sure everyone kind of recognizes the fact that there is a lot of math, obviously, before we can start some of the upper level engineering classes. As I mentioned, we do require 8 hours of physics. We have engineering physics 1 and engineering physics 2. This is Cal-based physics. What's interesting about our program, it's actually taught by engineers and not by physicists. So Dr. Andy and Dr. Chaglian teaches those classes. We do that because we want to make sure our physics is specifically geared toward our engineering program. Additionally, we do have chemistry, and that I just want to let you know. The good news is y'all will probably be affected by this. We will no longer require chemistry 2. And a lot of students, yeah, I'm getting claps. A lot of students do not like chemistry 2. However, chemistry 1 will still be required. The good news about chemistry is it's just algebra based, so you don't need a lot of math to do that. However, we do require 4 hours of chemistry. However, what that means is right now you're required to take calculus 1 and calculus 2. Most of y'all will be probably be affected by this. You will be required to take calculus 3. So instead of chem 2, it will be cal 1, cal 2, cal 3. We've decided that you all need more math than obviously chemistry. We do have linear algebra. This is matrix algebra that's required for most engineering classes and a lot of computer programming, especially in artificial intelligence. We have differential equations. And then after all that's done, and that's all from the math department, by the way, then you take engineering analysis, which is taught by engineers, and that is basically engineering math. So all that calculus, all that linear algebra, all that differential equations is then kind of reviewed with y'all by an engineering professor, but it's geared specifically with engineering applications. So we do take our math very seriously. So you all will be very strong mathematicians. And this is why we have quite a few students who actually get minors in mathematics, because we just you're spending so much time in it. Our lower core, and yes, Chris is saying like, is Cal 3 vector calculus? Yes, that's all the 2D and 3D vector mechanics. We use it for basically equations of motion and for electromagnetics. So yes, it's all the vector calculus. Our engineering lower core is fun. Most students really enjoy it. We have introduction to engineering. Some of the slides I'm doing right now is actually from that class. We have engineering graphics 1 and 2. It used to be AutoCAD, but we're shifting over to SolidWorks. So most of y'all will probably be learning SolidWorks when you come over. A lot of companies here in San Antonio love to hire freshmen and sophomore students that have engineering graphics background. So can they do CAD, computer aided drafting drawings? So quite a few of our students start getting jobs pretty early to help with drafting. Good question about from David about programming languages. The programming language that's taught in engineering is MATLAB. But the good news is, since the engineering department is also responsible for computer information systems, we also teach Python, we also teach C#, and we also teach C++. So we've got all the major programming languages available. If you're interested in web design, we do HTML, we do a little bit of Java. So pretty much all the major programming languages are out there. However, for the engineers, the base language is MATLAB. But for the folks that may want to get a minor, say in computer information systems, we teach all the other languages too. And our department is responsible for that. We also have a calculus-based engineering probability and statistics is very important to be able to determine like mean time between failures and things like that. Upper level core, I'm just going to highlight some of the big classes. I teach all the electrical stuff. So I teach electrical circuits and electronics. Obviously, those classes are fun for me. We do have a capstone the senior year, which is geared toward building a product. So you'll actually work with 3 or 4 other students over the semester, usually from CIS and cyber. To build a project of some sort. Usually it's a product, and it's a kind of a culmination of all the things you've learned over the years. Internships are always important. Most of our students start to intern their junior year. And I know this is international, so there are some requirements on that for some of these companies. But we do have a pretty healthy internship program. Boeing hires our students. HEB is a local grocery chain. They hire a lot of engineers to do data analysis. So they're really, really sophisticated stuff. The National Security Agency is here. This is our spy agency. They have a big office here. USA is a large insurance company that does data analytics. They hire also a lot of engineers, and they have a giant drone lab, surprisingly enough. And yes, yeah, and Michaela's saying yes, there's job fairs every semester. Southwest Research is a research institute here that does very, very sophisticated engineering projects, and they're always reaching out to students. The FBI has internship. That's more U.S. citizen. We have Rackspace. They do a lot of cloud storage stuff. So we're pretty active in terms of student employment. And there should be more than enough opportunities to kind of get those skills that you need to make yourself marketable. So this is kind of the overview of the program. I want to give you a little bit of taste. I'm showing that we've got about 23 minutes I want to give you a little bit of a taste of a class. But before we do that, please take a picture of this or just grab it. Please get my email address. More than happy to answer any offline questions, or you want to have an individual Zoom meeting with me, happy to do that. There's a question about what programs are used to make programming codes. The primary two is MATLAB. Engineers do most of their programming using MATLAB and Simulink. So our drones are actually operated using MATLAB and Simulink, but we also use Python. So those are probably the 2 biggest languages that we use in order for projects and things like that. C++ is becoming a little bit more popular, but I'll let you know that's a hard language to learn. Requires a little bit more skill and training to do that, but we've been teaching that for the last several semesters. Good questions. There's questions about financial aid and scholarships. Yes, they're definitely from the academic side. There is lots of scholarship opportunities based on the grade. These are merit scholarships. Additionally, there are specific scholarships that are geared toward, like, say, engineering, things like that. For the athletes, there's also there's athletic scholarships available. Okay, I'm just gonna give me a second here, looking at the chats. And yes, so I'm actually at 11:30. I'm going to give another talk specifically for CIS and cyber. So if you guys want to stick around and listen to that, kind of the same, a little bit the same initially, but in the mock will be this. The mock classroom stuff will be the same, but I'll give you different information about CIS. Okay, I want to be respectful about the time, so I'm going to stop sharing and cut over to my other slide. And this one is what I'm calling Introduction to Artificial Intelligence. So one thing that I'm really interested in is AI. And I think, most of y'all have heard it, about it. It's obviously a very, very, very big area. What I'm going to do for the kind of the remain, at least for 10 minutes, so we can answer questions. I just want to give you a flavor as to what a class feels like. Now, bear in mind, this is an upper level class. So this is engineering 4399. So this is a senior level class. And this is actually my first day slides that I would do. So so I'm not going to get mathy on y'all. So I don't want you all to fall asleep. I just kind of want to give you an idea of what a class feels like. Most professors are not big on PowerPoint, so we kind of minimize that. But since this is virtual, I wanted to do this obviously with a PowerPoint. I'm the type that likes to work on a board, so just to let you know. And again, most of our classes are face-to-face. So I spent a lot of time on this area called machine learning, and just wanted to kind of tee up what we mean by machine learning. You can kind of tell by the name that machine learning must mean something about having the machine or the computer program learn by themselves. So a lot of questions about computer programming. So we teach a computer programming class at the sophomore level, and I teach that. How is it different from machine learning? Well, you can see it by the way the data is flowing. So with computer programming, what we do is we give the computer, your laptop or your desktop, we feed it a lot of information, like the pricing information for a stock, like Microsoft. And then we give it a program, like a MATLAB script or a Python code. And then what happens is the computer does some stuff looking at the data using the MATLAB script, and it gives out some outputs, it gives an answer. So how is machine learning different? Well, notice something. With machine learning, we still have the computer there in the middle, but we've changed the inputs a little bit. Instead of having a MATLAB script, what we're providing it is data. Again, the price on stock for Microsoft, but we're also giving it answers, some sort of outputs, expected outputs. And what happens is the computer learns from the data, the stock prices, and looks at the outputs. The output could be buy the stock or not buy the stock. And the computer then builds its own code. So machine learning is kind of like computers that build their own programs based on output data and input data. And that, in a nutshell, is machine learning. Very neat. And it's a different way to look at how to program, which is why you have to know how to program before you can do machine learning. And this is, again, a very cutting edge area of artificial intelligence as a subset. Where do we use machine learning? Well, I think a lot of y'all are very familiar with like facial recognition. It recognizes patterns. If you walk around UIW, if you're here at UIW, you'll notice there's these cameras at the entrance of every school. What it does, it looks at your face and takes your temperature. That's basically pattern recognition. It's looking for a facial outline and then taking the temperature to see if you can come in the building or not. So it's becoming very prevalent now, facial recognition. Your phone has it to unlock the phone. But you also see it with handwriting, and it's pattern recognition is getting very, very popular with medical pictures, photos like x-rays and things like that. Machine learning is very, very important, like in credit card transactions. If your credit card, like for some reason, is not working because it's been frozen, it's usually because there's a machine learning algorithm saying, hey, these purchases that were just made are not typical of the particular user. They kind of understand what you'll buy. And suddenly you're buying a sewing machine. It's like, you've never done that before. It'll flag it. So that's usually all machine learning. Machine learning is very popular in predicting things like prices. I'm talking, as an example, I'm talking about like American football. There's a lot of artificial intelligence that's trying to determine how a particular player will perform on a particular day. That's all artificial intelligence. And I know that's probably the same for football in general, international football, trying to predict what a team will do. So AI is very prevalent right now in society. This is Professor Srikanth. He's showing, we built our own facial recognition system. We were using Python, and you can actually see that it's saying, hey, you got a mask on or you don't have a mask on. We built this like in 3 hours. So it's really not that difficult. You'll look in the back, there's actually our part of our lab, and you see our drones there. So we do a lot of stuff. Something else that that machine learning is really important with is autonomous cars. UIW, we have something called the Q car. We have 5 of these things, and they're small autonomous cars. They have LiDAR on it. They have your typical RGB, electro-optical cameras. What's really important is we have a GPU. We have an NVIDIA Jetson. So we do a lot of what we call graphic processing unit programming, GPUs. These are those NVIDIA cards. This is something that some of y'all will get very, very heavily involved in because it's very important. GPU programming is it is huge right now. So we work on autonomous cars, and these are real practical things that you'll see machine learning being applied to. Here's an example of our autonomous car, a little loud. So that's one of our drones, an autonomous car flying. The autonomous car was taught just to drive in a circle, and it learned to drive in a circle, and the drone's tracking it. So this is the stuff that you see machine learning in, and you can see a little bit of our lab. Here's another one. This is really cool. This is outside. We have our flight operations team using some machine learning to fly one of our outdoor drones. This is what we call the X4P Commander, and we're out at a training yard at a power line or a power company, and it's got a camera. You'll notice it's got a camera on it on the bottom of it. You'll see it's actually detecting line detecting the power lines, and you saw some video of this before. I just kind of bring this to your attention. Students fly the drones. They all have special drone licenses from the federal government, and they work with the power line company. They actually go out and inspect power lines, and we collect a lot of data. And right now, this is a flight test. We're just trying to prove using machine learning that our system can detect the power lines. So lots of practical applications for machine learning. So machine learning, at least for the class that I teach, is broken out into 4 areas. One area we spend a lot of time on, which is called unsupervised learning. It's just kind of looking for patterns. It's kind of what I consider the simplest type of learning. Doesn't require a lot of data. The one that you probably are most aware of is supervised learning. This is all that artificial neural networks. This stuff requires lots of data, and this is what the area of data science. There is a newer field called reinforcement learning. This is learning based kind of on how we learn, trial and error. So we don't give it a lot of data. We just let the system kind of learn how to drive itself, and it's a neat field. And then through a lot of crashes, it learns, hey, don't hit the wall. We do deep learning. Deep learning is large neural networks, and by large, we're talking like thousands upon thousands of layers of neurons, and these take days to train. And we have servers that sit there, and all they do is train all night on some data. So unsupervised learning is what we call unstructured. And what we do is we look for patterns. And this one's kind of easy. You can kind of see by your own eyes that there seems to be 3 clusters. So we're doing what we call cluster analysis. And we can teach computers to kind of recognize those structures, those clusters for us. And unsupervised learning is used a lot actually in credit cards. They'll notice that a person never has bought a sewing machine before, and that would be an outlier, and that would flag it to an investigator saying, hey, let's put a freeze on that credit card. Supervised learning is a little different. It requires lots of data. And we use supervised learning for like classifications. An example of this would be based on the size of the tumor. Is it benign, meaning it's safe, or is it malignant, or is it cancerous? And as you can see, as the tumor size increases, at least for this, whatever this cancer is, it is classified as malignant or cancerous. So we can actually build computer systems that can classify new data based on that. So typically for unsupervised learning, it's a lot of just prediction, looking at outliers. Supervised learning is a lot of what we consider classification. So that's just kind of a real quick rundown, give you a feel as to what an engineering class feels like. But let me warn you, this was without any math. We typically do, there's a lot of math equations on most of these classes. These slides that you just saw were like the first day, and I don't typically dive deep into that. The reason why you spend so much time learning math is the fact that it's the primary language that we use in a class, and that's great for you all. If English is a second language, because most of us just speak math, and most of us understand math, and that's kind of how we deliver the information. So with that said, I'm showing you that there's about 9 minutes, and this is basically open to questions, and I'll be happy to answer any questions, and I may have to refer some of this over to Michaela for specific international stuff, but feel free to ask questions on the chat or just unmute yourself and ask away.
I got a question about the intro to CIS and cybersecurity class that we're hosting next at 11:30. I'm going to put the link to the sign up in the chat box if any of you would like to attend that session as well. Just register on there, and then you'll get an email with the join link. I also wanted to follow up on Sharad's question about financial aid and scholarships. I would like to mention the primary scholarship that we offer for international students would be the Merit Scholarship. And that's what you'll be awarded that automatically when you apply. And that is based on your overall high school grade point average. If you are looking for additional funding after that, I do have a few resources for you that you can check out. So again, the Merit Scholarship is the main one that UIW offers. But if you do earn any scholarships from your government or from outside organizations like nonprofits, you can apply those to UIW. So I'll give a resource in the chat box called Education USA. They have offices all over the world, so they have one in your home country, and they are college advisors. Their services are free, and you can ask them more about particular scholarships available in your home country.
Any questions? David has an interesting question. I'm assuming he would just be considered US.
American citizens. Yeah, so if you have American citizenship, you will apply as a domestic American student, but the requirements and the scholarships are all the same. Sherrod, I'm putting that link to Education USA in the chat box now. For Latin American students, there's also something called the ROE Fund that has low interest loans and grants available as well.
And Chris says he missed some details. Oh, okay, scholarship information.
Yeah, so scholarships are awarded automatically based on your overall high school grade point average. So when you apply, we will take a look at your transcript and you'll get that scholarship automatically. I'm going to go ahead and share my screen with my contact information if you would like more information about our scholarships. I will also put our website in the chat box. And I do want to note something really cool that we do have available on our website right now. It is a great option to talk to current UIW students to get that UIW perspective, student perspective. So if you go on our website, uiw.edu/international admissions, which is going in the chat box now. If you go there, you can chat with current UIW students. You can search by country, you can search by major, and ask them, for example, what is it like to transition to life in the United States? What is it like to live on campus? What's your favorite class? So these are all great things to ask our current students.
So David's asking, do we have master's programs in engineering? No. So again, UIW, at least for within engineering, we are focused on undergrad only. For folks that are interested in masters, and again, I can't answer for international, but I do know that a lot of our local students, once they graduate from UIW, they do go to the workplace, but some of them do go to our to the local state school, which is the University of Texas in San Antonio, and they have graduate and PhD programs. And I do know they take lots of international students. Good question.
Awesome. We have maybe like 2 more minutes in case you have any more questions. I did get a question about the minimum GPA. You need at least a 2.6 on a 4.0 scale to be entered into the university. But the higher the GPA you have, the more money you can earn in scholarships. So our scholarships range from $5,000 to $20,000 per year. If you do not use the 4.0 grade scale, that's okay. We will basically translate it to the 4.0 grading scale. And then we had another question for Dr. Frye regarding laptop requirements for mechatronics.
Yeah, we don't. I'll be honest with you. Most students have a laptop. You don't need the fastest thing out there. I mean, just get yourself a normal, something with an i5 processor with 8 gigs of RAM. Nothing special. I mean, should not have to spend a lot of money for a laptop. However, most classes do require you to bring a laptop.
Okay. Sorry. Go ahead, Dr.
Yeah, and there, Dave is asking about minoring. Yeah, we're pretty flexible. Economics, political science, business. I've seen it all. Art. I've seen minors in anything you can think of. So yeah, that's easy.
Awesome. Well, thank you so much, Dr. Frye, for your time. I know we need to transition to our computer science class right now, so I'll go ahead and end the session. Thank you, everyone, so much for joining us. We had a really great audience
Thank
today from
you.
a variety of countries. We really value that here at UIW. So please do feel free to reach out to me if you have any questions. I'm very active on WhatsApp. That is my direct WhatsApp number and email. So thank you so much, everyone. Thank you, Dr. Frye. It was a wonderful session.
Thank you, everyone.
We hope to hear from you soon.
Thank you all. Thank you all for your attention.